Hey Squids. Okay, so today we're going to start out class by looking at some of the things that kids have written in their assignment number 9. And all of these are right, but they are not complete. So, for example, the one student claimed that matter is moving from the speaker to the window. So, when we talk about the truck speaker moving back and forth, this person said that matter is what moves all the way to the window. And you can see her evidences, or his, I don't remember. We can see that the gas state of matter is floating between the car and window. Sound travels by matter, so we know the gas is carrying the sound from the car to the window, and that causes the window to vibrate. It's not quite correct. Another claim, I think that the particles are being pushed and pulled back and forth between the speaker and the windows. My evidence is that the windows are rippling and it looks as if a force is pulling them back and forth. This student is really on track because they looked at the simulation and they looked at the red particle and noticed that it was just moving back and forth, but they didn't talk about what is going on to get the particles moving back and forth all the way to the window. And the third student says sound waves are moving from the speaker to the window. And the things that are making the sound waves are particles with types of vibrations. The vibrations are making the particles collide to form that sound wave. Also, in the last experiment, we know that it's not air the sound is traveling through. Okay, so this one is excellent, and they talk about sound waves, but they don't say what the sound wave is. And there are vibrations, but they didn't talk about what causes the vibration. So we need to talk about that. And so in order to do that, we look back at the simulation and we also watch a video of a Newton's cradle. The Newton's cradle will help you remember potential and kinetic energy. Remember, because when we pull this up, there's potential energy, and you can see the energy is transferred from being potential to kinetic, and it is transferred to the other balls, and they keep transferring the energy back and forth. So that's a real clue as to what is going on here in our simulation, right? What is happening when the sound source starts moving? What's happening? It is actually doing what? It's a force, and it's using exactly energy to push the particles. The particles are not moving all the way. You can see, look at that red particle. It's not moving all the way across. What is moving all the way across? What is being transferred from one particle to another? That's what we talk about. Okay, so as we talk about that, we realize that sound starts with a force to start the motion of an object. When an object moves back and forth, it produces bands of compressed, that's when all the particles are smushed together, and expanded particles. And that compression moves through the medium. The density of particle compression, remember, they're more dense. When the amplitude and the vibration increases, the density increases, and then it releases. Collisions in the particles result in compression bands moving away from the sound source. The collisions transfer energy across the medium. All right, a wave is a movement of energy. So then we take some time to pick one of these to improve. And we draft your answer in your notebook, type it in the chat to me, and I give you feedback. So you pick one of these and realize, oh, it didn't talk about energy. It didn't talk about particles. And you add the new information to the claim and evidence, and then I give feedback on that. Once you get the feedback, then you add the evidence to your progress tracker. Then we share in a Jamboard all the things we've learned about sound by looking at our progress tracker and go through all of that. We watched this video of a new phenomenon, which is bouncing salt. It's linked in Canvas, so you can watch it. Basically, a person hits a drum standing off to the side, and then the particles of salt bounce. All right. And then we look at a model of it, and we notice the detail in this model. The drumstick is hitting the drum, and you can see here's a resting position, right? Here's resting position. The drumstick changes the shape of the drum. It bounces out. It pushes against the particles. There's areas of density and compression and areas of less density as they transfer their kinetic energy, right? The energy from here, from the mallet, gets transferred to the drum, which gets transferred through the medium of the air to the plastic, which makes the salt bounce. So this is an inspiration for our final model, which you do your final model. Okay, how is sound caused and how can it make something else, a window in the parking lot, move? You're going to create a revised model. You're going to use your revised gotta have it checklist, which is on the next page. It's your final assessment. Here's what you have to have. You have to have vibrations of the sound source, collisions between particles, and, sorry, I can't read that on my, energy transfer, and changes that happen in the particle density across the medium. Those should all be included in your final model. And don't forget, we have initial models, right? So here is an initial model, and we've already improved it. We've already talked about how the speaker moves, right? So include all of this in your model. We've talked about how it vibrates at higher and lower frequencies and bigger and smaller to change the volume, amplitude to change the volume. You need to fix in your model, you need to fix part B and C. This is not what is happening here. Traveling through the air. What's traveling through the air? We just talked about it. You need to add that to your model. And then finally, when that whatever is traveling through hits the window, what happens? Okay, that's what you need to get done. And you will have an opportunity to show me the model and get some feedback before you turn it in.